why don't you tell everybody about you? I'm going to drop a little bit of your bio into the chat, but I'd love for you to tell everyone about you.
Sure. So let me share my screen.
I have to share that for you. 1 second.
So first of all, yes, you can see my slides. You can hear me well. Thank you for having me as a speaker today. I am really excited about the conversation. And in fact, it's actually my first conversation style of presenting as well. So I'm nervous at the same time as much as I'm
You'll
excited.
be fine. There's no need to be nervous. You'll be awesome.
Cool. So talking about myself, my name is Purnima Nair. I'm a freelance .NET developer, and I'm talking to you from Langley in Berkshire. I'm a Microsoft MVP for developer technologies, and I'm also an Umbraco MVP. If you don't know what Umbraco is a .NET-based open source CMS. And I do a lot of work with Umbraco. It's my day-to-day job, and I've been an Umbraco MVP for the past 3 years. And non-work me, hey, it's not all about tech, is it? I'm a mother. I have a 7-year-old girl who takes up a lot of my time, which I absolutely adore. I read a lot. I love fiction. I read a lot. And you know, Leila, how it goes. You know my love for Harry Potter. I can bring in Harry Potter anytime to anything that I'm talking about.
I know.
And I am also a student of Carnatic music. I've been learning Carnatic music for a few years now, and I'm still learning it. So as much as I'm a presenter here, I'm also a student.
I think we all are. I think most developers are students for most of their lives, but there's always something new to learn. It's never finished, is it?
No, and once you are in tech, you are always learning because, as that video about Girls Who Code said, it is one of those streams of work which grows so fast and moves so quickly that we always are learning.
Yeah, completely true.
So,
well, thank you for the introduction to you. So, I guess we'll crack on. So, chat, make sure you're dropping in all of your questions for Purnima, and I'll make sure that we ask them.
So, Leila, REST versus gRPC versus GraphQL. I'm pretty sure you have come across this debate somewhere, isn't it?
I have.
Yes.
I've done GraphQL. I've obviously done REST. I think most of the web developers will have started with REST. And I've been to some talks on gRPC, and I've looked at it, and I've gone, I'm not so sure.
Let's see. So, again, talking about me, I am also from the REST world. That's what more I deal with. And I've been picking up gRPC and GraphQL on the side just because I want to learn about it. I have used it for evaluation purposes, but nothing more on a production level. So this talk was all about that learning experience for me, how I see it, and what more I could learn from the 3 API patterns. So I don't aim for a debate today because as much as all these are API patterns, I think it is like comparing apples and oranges because the 3 are so different in the way they work. So we will aim at a comparison. So first, we'll go through each of the API patterns. We'll talk about some of the basics, see how the time goes, go through most of the slides that I have today. And finally, we'll save some time at the end for the comparison work between the 3 APIs.
Perfect. Sounds like a good plan.
Yeah. So we are comparing API patterns. So I need a common ground to compare them. So we will consider a fictitious user database. I might bring in Harry Potter and wizards in between.
I was hoping there would be some Harry Potter. I don't think we could have one of your talks without it, as we've already said. So
So we will switch between user and wizards as we see fit. So we'll compare and start at the basics, and then we will see how or what happens if everybody at Hogwarts. Hogwarts is a social media platform. It's a fictitious social media platform. And what if Harry Potter starts tweeting and starts adding stories and comments to the stories? What happens? How will the API look like?
It's going to be one of
So
those talks, isn't it?
yeah, um, we will see how it goes. Let's bring in user or wizards or Dobby as we see fit. Oh, so that's fun. Well, we are learning. Tech should always be fun. I think that's the
I
way I
could
see it.
not agree more, Purnima. It should be a joy to learn and do.
Absolutely. So let's crack on with the first API paradigm, gRPC. So I'm starting with gRPC, and you will see why I'm starting with gRPC, then moving on to the rest. So gRPC, at its very basic, it's an open source, high performance, remote procedure call framework. So it's a flavor of something called RPC. So let's see what RPC is about before we talk about gRPC.
Okay.
A remote procedure call is when a computer program causes a procedure to execute in another address space, which is coded as if it were a normal procedure call without the programmer explicitly coding the details for the remote interaction. That's a pretty long definition, but
That
at the
went
very
whoosh.
yeah. At the very basics, hey, I had to put in a concrete definition, but at
Of
the very
course.
basics, what it means is I have a computer program which calls another, and this client computer program, what I'm trying to call, actually invokes a method. And that call looks like a local call, but it is actually jumping the network and executing it on the server. So it is a procedure call remote that happens remotely. That is what remote procedure call means. It's exactly what the name tells you is what happens behind the scenes. So it is smart at hiding what that location is. It hides the server from you. The client program doesn't know where it is making the call to. I'm just invoking a function. It executes, I get the results back. That is remote procedure call.
Okay.
This technology is not something that's new at the moment because RPC existed a long way back, as I understand or as I've read. Practical implementations apparently go back to 1980s, if I'm not wrong. So it's a pretty
Right.
old technology as well.
Yeah.
But and what the fundamental unit of remote procedure call, be it gRPC or be it any RPC, is functions, because you are calling functions. You're calling functions on another server, but
Okay.
invoking it as a local function. So functions are the basic unit of any RPC network.
All right. I'm just going to interject with a question, Purnima. So Thindle is asking, why don't we use SOAP with generated client for this?
Oh, I don't know. I have not done so for years now, but I can point you to some information. I think that's on Microsoft Docs itself. There is a good comparison of SOAP versus gRPC.
I'll see if I can find it.
Yeah, and apparently there is like an ebook as well called, ebook, which actually deals with the same subject. I haven't gone through it, but it is actually quite famous, and you should read it if you are a SOAP developer. If you use the web services and then you are moving on to gRPC.
Right. There's quite a lot. There's WCF to gRPC, so it's got to be around here. I found a comparison of SOAP and REST and gRPC as well. There's a lot of good things on here. So I'll have a look, and we'll have a look. I'll see what I can find as well. So this is kind of what I understood with gRPC is you write almost like this, a scope in a common language, don't you? And then you call it as a function type thing. So all right, let's crack on.
So I'll go through this slide very quickly because
Mm-hmm.
this is exactly what you said. I have the client calling a client stub. A client stub is nothing but a little kind of stub code which packs the parameters, passes it on to the server unpacks the parameters, actually executes the work on the server, and then returns the response back to me, to the client. This is
Right.
what happens in a nutshell with RPC in general. Talking about gRPC, this is something quite new out there because this is Google's open source implementation of RPC.
Mm-hmm.
It was initially called Project Stubby, and it became gRPC in 2015.
Okay.
So there is an entire site called grpc.io where you can read a lot of things about gRPC in general. But when .NET Core 3.0 came out, that is when we started getting official support for gRPC in the .NET realm. So as of now, gRPC is officially supported. We have all the templating. We have work going on continuously on the gRPC.NET front with for the
Yeah, I
support.
think I first saw a talk on it by Steve Gordon at ProgNet in 2018, September 2018, which is probably when .NET Core 3 came out, roughly, isn't it? I'm thinking
Yeah.
that came out in 2018, I think. Chat, correct me if I'm wrong, which I probably am.
So gRPC favors a contract-based API development. So it's a contract that you're trying to fulfill with gRPC
Okay.
when you develop an API with gRPC. And the first and foremost thing to learn about gRPC is that it's designed for HTTP2. So it makes use of all the nice things in HTTP2. I'm not an expert in HTTP2, but I know that there is things like multiple requests, that's request multiplexing, streaming, all those functionalities and features that HTTP2 gives you is something that gRPC.NET takes advantage of.
Cool.
So the next thing, one of the most basic things about gRPC is protocol buffers. Have you heard about protocol buffers, Leila?
Probably, but I can't recall them. So you just enlighten me again.
Yeah, sure. So protocol buffers is the communication mechanism in gRPC.
Okay.
So that's how data is transported. The request goes in and the response comes back. That is in protocol buffer format. In fact, if you have worked with Google IoT devices in the past, this term actually comes across there as well, because that's where I heard first about protocol buffers, and I was like, what is this? This doesn't make sense to me. But now when I'm picking up things on gRPC, it makes sense. This is an open source mechanism to serialize structured data, and the first and foremost thing is it is transmitted in binary format. So which is one of the reasons the messaging, the data that gets transmitted back and forth in gRPC is very small in size. With protocol buffers, data is structured as messages. So if you see on the slide, there is a message called person reply, and it has three fields: the first name, the last name, has a pet unicorn, and there are some numbers against it. So this is how you would create the structure of what your request or response is with gRPC. It's a message, and each message is a record of key value pairs, and they are called fields. So in my case, first name, last name, and has a pet unicorn. They are the fields. Do you have a question?
We do. I have some question as well. So FuelSnarble says, are there any tools that can let you take any protobuf message and make sense of it? So is this a protobuf message, this little thing here?
Yeah, this is how you define a message in a proto file, which I'm going to just come and talk to you.
That just reminded me. This isn't a C# object or a poker or anything. This is a specific new sort of language, isn't it? In a .proto file. Yeah. So we can circle back around to FuelSnarble's question if we get there as well. So
yeah, I think what Phil, what was that the name of the person who asked? A question?
Fuel
Okay, sorry. I think they were talking about some kind of tooling or documentation which can help you understand protocol file. I don't know about any of those generating tools, but I'm sure there will be one or two lying around. I'm pretty sure there will be. I don't know whether the testing tools can help you make sense of that as well, because I cannot remember on top of my head about that. There could well be something that that helps, but in all honesty, protofiles cannot be used as a documentation. You will see why.
Okay.
So protofiles, they define the contract of the API. So what the definition of the gRPC service is goes into this protofile.
Yeah.
You have all the procedures that you make up that makes up the service in your protofile, and of course the messages that are sent between the client and the server. So the message, the person reply that you saw on the screen before, the slide before, that also is a part of the protofile. So it's a syntax for a message that you put into the protofile. And here is what a protofile looks like. So you have the syntax, which is proto 3 at the moment. We have an optional C# namespace. This is taken from the Visual Studio out of the box template. So
Right.
it will have a C# namespace. There is a package definition as well called greet. And then you have your service. In my case, greeter is the service.
Yeah.
And you have your procedures or functions. In this case, there's just one called say hello, and it is not a function or a procedure, it is an RPC. That's the keyword here. So the
Okay.
say hello RPC accepts a hello request, which is a message. And if you see here, there's a message called hello request
I see.
with
Yeah.
just one field called the name. The reason why I need to have it, even if the message is empty without any fields, it still needs to go into the RPC, because RPC in its native form has to accept something.
Right.
Even if it's an empty object, it has to accept something. And it returns another message called hello reply. So what I showed you in the previous screen is a proto syntax of a message.
I got you. Yeah.
And because we have this first class support for gRPC.NET in the .NET world, what happens underneath the hood is there's a lot of code getting generated for you with the gRPC tooling. Each service on the server side, it creates a service class called, say, greeter.greeterbase. So which is the service name followed by the word base. And then each of the messages, be it the request message or the response message, corresponding POCOs are generated for you. You don't have to work around it.
Oh,
This is done
okay.
for you.
That's convenient.
Yeah. And the service class that gets generated, I think it's an abstract class with each of the RPC becoming virtual methods, so that you can then override them, create your own implementations for it. So this is where the contract comes in. So you inherit from greeter base, and then you override the methods, do the function or execute the function or add code as see fit, and that code is what gets executed for you. So this is on the server side.
It's like an interface, how you would use an interface, or as you say, an abstract class in general, to give you that contract. So, and that contract spans two different applications then, doesn't it, by having this common language? And that other application could be in Python or Java or anything, because this is so generic.
Yes. So if you have this protocol, the proto file, you can generate the code on the server side as well as the client side. So again, this is from the .NET world that I'm coming. So the same service can help you generate some client code as well. So it creates a client for you, which means I have all the methods local and handy to me in my client. So I'm invoking that method on the client, and it knows where to communicate it to. It knows where to go and execute the function, get back to me with the result.
Okay, that's cool. So we have another question, again from Fuelsnable. How do you share the contract? Is there an endpoint? So if you've got your two applications, how do you share that common contract between them?
Yeah, so protofiles are required to generate the client. So the things that I've read about sharing the protofiles is you can have a NuGet package of your protofile and then share it across your multiple projects. You can have a single project with your protofile with the client as well as the server-side code generated in that for you if you want, or you can plain and simple share the protofile across your projects as you see fit. So these are the three ways that I've read about. If there is anything else, let me know.
I would say you could probably have it in like a GitHub repo so that it was more generic, and then you could use that as a sub module, perhaps.
Yeah. Talking back, I just remembered something. Phil Snibble, they asked me about documentation around protofile. There are ways and means to display the protofile as an endpoint itself. So if you have like a REST API sitting in front of the gRPC service, you can actually display the protofile as plain text in your browser. So that's one way of sharing protofile as well. I've seen a nifty example somewhere about it.
So that might be similar to what Steve Talks Code is talking about, asking if the protofile can be exposed in a similar way to Swagger OpenAPI. That sounds like what you're saying there. Yeah.
Exactly. So there are ways and means to do it, because at the end of the day, it's a file. As you can read the content and display it, that's all what you need.
Yeah.
But you need the file somewhere, a reference to it to generate the client is what I understand about it.
Okay.
And this client code and server-side code generation is controlled from the CS Forge itself. There's a particular attribute for the protofile include called gRPC services. If it is set to server, it generates the server-side code. If it is set to client, it generates the client-side code. It can be set to both, which is the default, in which case it generates both the server and the client-side code, or it can be set to none. So if you have a big library of protofiles, you would probably set it to none and then reference that protofile in your server-side or the client-side project, change the attributes of gRPC services, and generate the code as you see fit, according to your situation. I think there are many ways and means to it, but I think there is an element of DevOps when you deploy a protofile out there. So talking about the API, how would it look like? How would the API that isn't sitting in front of a Harry Potter database looks like? If you want to have a simple CRUD operation, you would have get users, say get user by ID, create user, update user, delete user. Very action-oriented endpoints or action-oriented methods is what we are looking at with gRPC. And if you're extending Hogwarts to be a social media platform where each wizard and Dobby have stories, then you would have get stories for this particular user. Say get story by ID. You can have top user stories, story comments, latest activity, all of that in very focused or purpose-built methods, I would say. So there's a lot of functions or procedures going on with gRPC.
Okay.
We will briefly talk about gRPC methods as well before we move on. gRPC, as I said, is designed for HTTP2, so it's not just one request in, one response out kind of mode that we are dealing with. That simplest form of communication is called unary. That's the basic one. We also have streaming methods with gRPC. The first one is server streaming, so in which the client sends in a single request, but server starts to reply with a stream of messages back to the client. So it's quite instant. The minute server places something on the stream, you get a reply in the client. So it's quite instant. You can see the messages coming in.
And that's utilizing some of the features of HTTP2, isn't it? Because that has more of that open stream of communication rather than just a request response type process. Yeah.
There's also the client streaming. So in this case, client sends a stream of messages to the server. The server waits for the stream to finish and then processes the reply back to the client. So it's a single reply from the server, but the client sends in a stream of messages.
Okay.
And finally, there is bidirectional streaming. So in which case, client sends in a stream of messages and the server starts processing and sends a stream back. So there is streaming both ways as well. So this I feel is one of the unique capabilities of gRPC. The streaming is quite unique. So when we go through REST and GraphQL as well, you can see each of these API patterns have their own uniqueness. And I think the streaming capability is one of the unique features of gRPC.
Okay, cool.
There is information about metadata, but there's one thing that I want to talk about. We have request headers and response headers with gRPC. You can have content in the headers, but because we have the server streaming and bidirectional streaming where the server actually streams back, there's also the capability of adding trailers. So unlike the headers, trailers comes in once the streaming from the server has finished. So if you want, if the server did not process all the messages or errored out in the middle, so the trailer is a way of sending that error code back, or telling you, say, if everything is completed successfully, it can tell you how much data it processed or something like that. So another unique feature in gRPC is this.
Right.
There are a few slides more with gRPC, but I'm going to skip this because we need to move on to REST now. I have put the slides out there in my resources link, so
Perfect.
you can actually go in and get the slides and have a look at it as well.
And I think once we've looked at them all, Purnima, we can compare like the how performant each one is and things like that. I think that would be good once we've looked at them all.
So REST API, this is probably one of the most successful technologies of all time in the world, and probably the most widely adopted API paradigm as well. Think of any developer who has done an API, they are pointing this way, REST. But are all the APIs that we all develop truly REST? That is a question for later. But I think all API developers at some point might have come across the REST word. That's for sure. Without much delay, REST stands for Representational State Transfer, and it was first presented by Roy Fielding in 2000 in his doctoral dissertation. And that's how we started to get knowledge of this particular term. And he presented REST as an architectural style for distributed hypermedia systems. So it's an architectural style, it's not a specification or anything. It gives you top level or high level information about how you could implement a distributed hypermedia system. How you implement it is up to you. So it's top level things that REST gives you. And with REST, the fundamental unit is resource. A resource can be anything which can have a representation. It can be a person, it can be a wizard, it can be a car. They are all resources. So what REST tells you is, here are some resources. I can tell you how to act upon them. You can talk about a collection of resources. You can know how to model a resource. That is what REST deals with. REST was actually presented for distributed hypermedia systems, or from my understanding, it was more about web that ran on HTTP at that point.
Okay.
But we are bringing that down into the API world as well. This is what I understand the more and more I learn and read about REST. Resource identifier. So every resource in REST has a resource identifier. So if I'm talking about a user will have a user identifier, which is the URI in simplest terms. And every resource has a representation as well. And that representation is put together with the data about a resource, say Harry Potter, headline, the ID, that's all data about the resource in question. Then you have some metadata in the form of headers, and you have some hypermedia links. This is how a resource representation is supposed to look like in REST. So you have the data about the data, as well as the links. This makes up the resource representation. And as developers, when we communicate with the REST API, we give it a resource representation and we get back resource representations.
Okay, because that looks like, seeing that just reminds me of Hatios, that's all.
Yes, we will talk about it in a minute.
Yes. I'm like, oh, hang on a minute.
Yeah. Uh, so, REST is made up of 6 constraints actually. This is what actually defines REST. The first one is client server, which means I have a client, it talks to a server, there can be many clients. The server is not supposed to know of any client. So if the client doesn't send any request, the server is not supposed to know of that client being existent. And the server is supposed to give out responses without any delay or any issues. That's the client server constraint at its simplest term. Stateless. So stateless in its simplest terms, I think, is that if the client is not sending any requests, the server doesn't know about that client being existent. In other words, any session information about the client should be managed and stored only by the client. It should never be the server knowing about the client or the session. That is termed, if you do that, that's termed as an abuse by Roy Fielding, apparently, of the system. Cacheability is another constraint. You don't need to necessarily cache every response that comes out of the server, but you can cache it as you see fit. And such cached responses can then be served for equivalent requests from the client. And that cacheable, or the information that that the server sends out, is supposed to contain information about when to invalidate cache and how the client is supposed to manage that cached information as well. So that's why you can see certain headers in the metadata that goes back to the client.
Cool.
Next is the most important of the constraint, which is uniform interface. This has, I think, 4 different sub-constraints, like every resource must be something, must have the capability to be uniquely identified, like a unique URL. You should be able to manipulate resources using representations. You can send in a representation, manipulate it, and get that response back as a representation. And it can have multiple formats as well. So JSON, XML, text, HTML, all are such valid representation of resources. REST doesn't say this is the format, but it can have multiple formats.
Cool.
The messages must be self-descriptive, which means everything that comes back goes into the server must have the information of how to handle it. The server then handles it, sends back the response. Both these messages are self-descriptive, and it should be a unique request. So the client sends in a request, server responds back, and the server forgets about it. Nothing on the server side is dependent on anything which came before the request or after the request. It should be independent. Okay. And finally, we have Hatios. It is a very intimidating term as I see it, but I found a very simple way to explain it. I read about a simple way to explain it. If you navigate the web, you can put together, say, a collection of links, a collection of web pages making the links up, and then such collection of web pages making an entire website. That connectedness is what Hatios aims at, because the client should be able to make a decision on what the data that comes back from the server does, rather than me telling it what to do. The client should be able to move around, and that's what makes the client and server loosely coupled in reality. So that connectedness is what Hatios actually means.
I mean, it's good when you see it. If you've got external APIs, like you're selling an API, I think it's fantastic because it allows the client to navigate around the site. I've had to implement Hatios in a system, and it was horrific. It was awful, and it was just like, oh my goodness. And we only had it in one API endpoint because our technical lead wanted to experiment. So we had regular REST endpoints everywhere, and then we just had this one little tiny section that he wanted to experiment with. And so we all had to learn how to manage that and write for that. in just that one area. And that's why I'm like, but
Yeah.
Steve has a good description for it. It's like filling in a dot-to-dot drawing. I think that's talking about your connectedness. So that's another way of visualizing that, which I really like, Winema. Thank you.
Yeah, I really like that explanation as well, because Hatios as a term was very intimidating for me, because there's a lot of technicality going on in that acronym, I see. The next one is layered systems. So this is more about the deployment side of your architecture. So any RESTful system is layered, which means you can have like gateways, proxies, you can have like an authentication layer, you can have some other layer which talks to an external API or something. All these layers build up your RESTful system, and RESTful system indicates that every layer talks to one layer above and one layer beneath it, and each of the layer it should have the capability of being removed or replaced without much issues.
Okay.
So it's, as you can see, this REST constraints are put in place to make web a better place. This is how I see it. The last one is an optional constraint called code on demand. I don't think this is much important in the API world, because this is more about serving executable little snippets over your web. I don't think this has got particular intention on the API side of things. Quickly talking about some myths in REST. Just because you serve JSON over HTTP, that's not REST. Been there, done that. Every time you serve JSON over HTTP, that is REST for most people. At least for me, it was, until I picked up the REST constraints and I decided that's not REST. It's simply an HTTP API or JSON over HTTP. Another one, REST, is RESTful procedure call. This is a mix of using HTTP to invoke remote procedures like we have in gRPC. That again is not REST. And the biggest of it is that REST equals HTTP, which again is not. HTTP is a protocol and REST is an architectural style which was put in place to make web which ran on HTTP a better place. So you would find similarities. And because of that, what we do is reuse HTTP. Because REST was put in place to standardize web which ran on HTTP, it's always the easiest to implement a RESTful API using HTTP, making use of its toolbox, like caching, headers, all of that. What we have with the REST API is a root endpoint, and the users are supposed, or the client is supposed to navigate around it like a website would, or how the client would navigate around a website. That is how it is supposed to work, which is quite intimidating for me as well. And what we get with REST when it comes to the endpoint is a unique URI per resource. So in our case, let us say users are the resources, and we have a unique URI called /users, api.xyz.com/users. You would use the HTTP verb get to get information about the collection or a particular user. You would post to the endpoint to create a user, put to update a user, again passing in the ID, and delete HTTP verb to delete a particular user, again passing in the ID. So these are the basic 4 kind of actions that you can have. There are many other HTTP verbs, but we will just move on for the time being. Now let us extend the API to that Hogwarts social media. Do you think this is what we are going to get?
I don't think it's going to look like that, no.
Nope, it's not supposed to be like this. And this is where Teos comes in. This is regarded as the REST Nirvana.
Oh my goodness, I need to screenshot this one, because like I'm just...
This is actually the glory of REST, apparently. It intimidates me, hypermedia, as the engine of application state. You must understand that REST is actually not a specification or a best practice. It is how you can do it, but how you do it is up to you. So the biggest pain point with Hatios is, how do we implement it? Is my implementation correct? This is always the question that you would have with anything around REST, I think. So
I'm still reeling. I'm sorry.
so if you imagine a website, that's how your API is supposed to look like with REST. And that discoverability is very important in a RESTful system. And that's what Hatios gives you. What the client can do with the data that comes back to it, that is answered by Hatios for you. And it's that connectedness and it's that discoverability which is supposed to keep the client and server loosely coupled. So Leonard Richardson put together this model called Richardson Maturity Model, which actually tells you how mature your system is as a RESTful system. So there's a very good post by Martin Fowler on this topic where he clearly explains these levels to you. I've put this link in my resources. It's a highly recommended read for anyone to know this. At level 0, we have the swamp of plain old XML where we just have one single endpoint using HTTP for communication and getting back XML data or some sort of representation. At level 1, you start to think about resources, but we are using HTTP post, not all the verbs. And it's more like a remote procedure call invocation at level 1. Level 2 is where most of the real world APIs leave, I think, which is where we have the resources, we have all the HTTP verbs that we spoke about coming into the picture as well. The get, post, delete, put, patch, all of that comes in there. Level 3, when we actually introduce the hypermedia controls into our representation, is where we have the glory of REST, which is Hatios. And this is how a representation can look like in such a case. You have the information, the metadata, which comes back as the headers, as well as the links that comes back to you. As of now, there is no standard about how to implement Hatios, and that was where I got stuck as well, thinking, hey, is my implementation right?
Yeah.
But HalXML and HalJSON are the suggested kind of standards, but they are not anything of a standard even at the moment. Let's just skip on a few slides again and then come to GraphQL, which is the last API pattern for the day. So GraphQL was put in place because of REST chattiness. So imagine you have an API which actually tells you here are the users, then you navigate to each user, go and get the story. For each of the story, go and get the comments. That's a lot of network hopping going on, which was the very reason GraphQL came into existence. So we all know the story, I suppose, about it. Facebook was banned for its first mobile app when it used REST as the API, and there was a lot of battery drainage and network hopping going on, and GraphQL was the answer that the engineers came up with. GraphQL is unlike the other two. GraphQL is a query language for your API and a server-side runtime for fulfilling those queries with your existing data. So when it says it's a query language for your APIs, you can easily feel that client-centric, experience-focused APIs, because I, as a client or a consumer, has the ability to write a query for my API, get back the data that I need. So unlike the other two, GraphQL is very client-focused and very experience-driven API. It's made for mobile.
I enjoyed using GraphQL, but I saw a talk from Irina Skirty. She talked about how you implement it, and it was quite complicated.
Yes.
You have, there's libraries to help you do it, but it's not super straightforward.
No. So GraphQL, so REST is not a specification. gRPC is more like a specification because there's a very rigid, solid proto syntax.
Yeah.
GraphQL is actually a specification there is an entire GraphQL specification telling you how you need to implement that GraphQL specification. It is very hard to implement. In the .NET world, there are two libraries that can help you, GraphQL for .NET and Hot Chocolate as well. So two libraries that you can use to create GraphQL APIs. At the very basic definition of GraphQL is you specify types and ask for specific fields on specific types. So you are seeking information about types, but you are at the liberty to choose what information you want about a particular type. So say, for example, Harry Potter might have an ID, a name, a description, and the type of wand. I, as a consumer, can say, I only want the ID of the particular wizard and the wand type they use. So which means I get only that information. What you get with GraphQL is a single smart endpoint. There's just a single endpoint, but that endpoint takes in queries and builds the data output. So GraphQL is like a middleware. It sits on top of your existing data, and it is more concerned about giving your data the shape that you ask for. So if you look at my slide, on the left is my query. I am asking for a course of ID, say 1045. And I'm also asking for some extra information about who are enrolled into that course. So this is on top of the EF core example I've got on Microsoft Docs that I built this on. So I can also reach out to related information with GraphQL, but this is not something that you can do with REST or gRPC unless you really go about it. But with GraphQL, you can actually seek out hierarchical related information as well. And what you get back is a JSON representation of the data, but the JSON that you get back is an exact mirror image of my query. So which means it's more predictable kind of JSON that I get back. And also, if I ask for a field, I get only that field. I cannot choose all the information from a type in GraphQL. I have to be really specific about it. So it's like a smart person which tells you, hey, tell me where you want to get this information from, where and what information you need, and that comes back to you.
Yeah, because there's all these cool explorers, which I played with. I played with the one on Contentful's site, and it helps you build your queries, and once you get your head around it, it's really logical, but it takes a little while to get it into your head.
Yes, that's actually one of the comparison points as well. The learning curve is pretty high with GraphQL. And the fundamental unit in GraphQL is query. You ask for data, and you get the data in the same shape. There are some features of GraphQL. There's one or two things which I wanted to highlight here. The first thing is that GraphQL is introspective, which means it has the capability to query itself and understand more about the API in itself, which means that it is quite an interesting feature, and it has given rise to self-documenting tools like GraphiQL and GraphQL Playground, which is just more than a query testing ground. It gives you documentation as well.
That's
and
awesome.
GraphQL is regarded as a version-free API as well, because there are ways and means to obsolete, mark data as fields as obsolete, and unless the client consumes a field, that field doesn't exist for a client.
Okay.
The heart and soul of any GraphQL system is the GraphQL schema, and all the implementations, all the libraries helps us build this schema. We don't have to do too much about it. Schema is made up of types. The first one is the object types. So if we have a user is a type. If we have a story is a type. Comment is a type. Then you have your root operations as well, which are types. So the first one is the query operation type, which is for getting the data. The mutations for inserting, updating, or deleting data. And finally, subscriptions, which is one of the standout points with GraphQL, is for pushed updates. And this makes up the types in schema. So be it your operation type or your object types, they are all types. And types are made up of fields. So if you have your user might have an ID field, a name field, or a description field. If you have your query operation type, you might have, say, fields to get a particular user or get a collection of users, and so on. So each type has fields where each field has a name, a scalar or a complex type which it resolves to, and the resolvers which actually take care of how to resolve a field to data for you.
That's really interesting with those, Purnima. Now, I just want to tell you that we're getting quite tight on time, and I know that you wanted me to make sure you got to your comparison slides.
Yes.
So I'm just giving you that. We may want to go to your comparison slides.
Yes, sure. So the first, we'll quickly have one-liners about this, and we'll go to the comparison. So the query operation, the most common way to use a GraphQL endpoint is over HTTP. And unlike REST, we use POST, a HTTP post to actually get or fetch the information, because the query goes in as the request body into the API. There is mutations for inserting, updating, or deleting information. Again, happens over an HTTP post. Subscriptions, which are the standout points about GraphQL. These are updates pushed from the server. So whenever a user is added or whenever a story is added, if you want all the clients who are subscribed to this subscriptions from the server, they get updates from the server. So it's clients can choose to listen, but the server continuously pushes the updates to the clients. Again, happens over HTTP post, and they are stateful as well. A quick word about the fields. So my query could have the users and user field because query is a type. Mutation type could have the create, update, and delete user as a field. Subscription could have user added, user updated, and user deleted as the field as well. These are some examples of queries as well, which I have. This is all GraphQL queries. Let's skip this for now. Yeah, how they compare. So you might have noticed this is like chalk and cheese. They are all so different. Now, so the fundamental unit with REST resources, GraphQL is query. Coupling is low or supposed to be low in REST. It is low in GraphQL because the client decides what they want. gRPC are put together as high coupling or a level of coupling because it's a contract-based API. And I feel that anything contract-based has a level of coupling. REST is very chatty. GraphQL is low in chattiness, and gRPC is medium. Caching, HTTP caching is made use of in REST, while as with GraphQL and gRPC, you'll have to resort to custom methods of caching. Discoverability with the HATIOs implemented is good in REST. It's really good in GraphQL. If you have seen a GraphQL playground, you can actually see the docs. gRPC is pretty bad, unless even a proto file cannot make up for it, I think. Versioning can be needed in REST. GraphQL is supposed to be no version. gRPC also can need versioning. Statefulness, all the three are stateless except for subscriptions in GraphQL because it needs to keep track of the clients and what the clients ask for as fields. Performance is good in REST, is good in gRPC. It's actually really good in gRPC. GraphQL can suffer on complex queries. Payload size can get heavy with REST, medium in GraphQL. It's lightweight in gRPC because of the binary format. The payload format, let's keep it as JSON for now in REST, but in ideal world, it doesn't specify what the payload format is. GraphQL, you get back JSON, and gRPC, it's binary format. Browser support, except for gRPC, it's okay with REST and GraphQL. With gRPC, it requires gRPC web. So if you want a Blazor application talking to a gRPC endpoint, you need to make of gRPC web, which actually acts as a proxy between HTTP 2 and 1.1 requests. Standard, as far as the standard is concerned, REST is only best practices or top level things. GraphQL is a formal spec, gRPC is a formal spec. Maturity, REST is the most mature, while the others are still kind of building up the ground. Learning curve is the highest in GraphQL, while the other two is medium. Learning resources, maximum amount of resources in REST, while the other two are still few in number. .NET support out of the box for REST and gRPC, while as GraphQL is third-party implementations. Visual Studio support, again the same. You are relying on external templates for GraphQL. For hosting, REST is pretty okay. App service, Azure Functions, container apps, all of that can be on REST. GraphQL can be app service or Azure Functions. With gRPC, it's Kubernetes service or container service in Azure Web. Azure, I think Azure Web App still has a problem with doing gRPC, unless
So
in
it's quite
gRPC Web.
interesting. You start to see, because of these hosting options, that's going to narrow you down to the use case as well. And you can start to see how it dictates when you might want to use it.
Yeah, with gRPC, one of the most common use cases is you have the gRPC endpoint, then you probably have a REST endpoint sitting on top of it, probably like microservices.
Yeah.
In fact, in my slides ahead, I've got some use cases as well. So feel free to have a look at the slides, which I have put together in my resources link. I have done a full-fledged talk on the topic as well in the past. Again, the links for it are in place. Let me just get to the resource slide. So that is my resources.
Let me pop that in.
Yeah.
I've also shared the YouTube video of this talk in full, which also has resources, I believe.
Yeah. So I think this actually, I have updated the page behind this bit.ly URL, which contains the YouTube video, everything,
Yeah.
the full slides, everything, in fact. So it should be easy for viewers to figure out what's going on.
That's awesome. Okay, I've shared that link as well in chat. It might not be clickable, but I've done it. Wow.
And thank you.
So
it was fantastic. And thank you so much for having me once again as a speaker.
Oh, Poonama, it was fantastic. But we disappointed Thindle, I'm afraid. And because we didn't get whatever this endpoint was, Wingardium Leviosa. I assume that is a spell. I seem to remember from my limited Harry Potter knowledge. I'm sorry. Am I going to be booed off stage now because I don't know enough about Harry Potter?
I think there is an entire site dedicated to Harry Potter somewhere. So I wouldn't be surprised if there is an API out there around Harry Potter.
Yeah.
There is,
and you haven't found it?
No, I haven't. I have searched for it. But there is this fantastic site which gives you more than information that you have in the actual books about Hogwarts World.
And you live on there, don't you, Poonama? You're like, yes.
I love bringing Harry Potter into my talks.
And speak of Irina, I was mentioning, Irina, your talk on GraphQL earlier and implementing it. So good morning to you, Irina. Well, afternoon.
Hi, Irina.
To you.
Nice to virtually meet you.
So that was fantastic, Poonama. Thank you so much. And it's always such a joy to hang out with you as well. We always giggle so much. So
yes.
Thank you very much for kicking off